Hey guys, welcome again to the Maths Club. We're going to continue on our series on sequence and series. So before we begin, there's something I just want to say. If this is the first time that you're joining or you're just watching this video in isolation, I would advise against that. If you head over to our YouTube channel, you'll see this column called playlists. Right? So whenever you're watching the video for the first time, always try to ensure that you're watching it from the beginning. So for instance, if I go to this fraction, decimals and approximation and I view the full playlist, you will see where we started from. We started from what is fraction, we went all the way down, and then at the end of it we went to WAEC past questions on fractions, decimals and approximation. So this is like the format that if you want to get the best out of this particular channel, this is how you need to watch the videos, watch them sequentially, and then use the WAEC past questions to sum up all of the knowledge that you have amassed so far. So geometric progression. A geometric progression, also known as a geometric sequence, is a sequence of numbers where each term after the first term is found by multiplying the previous term by a constant factor called the common ratio, meaning that the old number, I'll just multiply it by a common ratio. So I'll keep on multiplying. Let's say it starts with 2 and the common ratio is 3, so that will be 2 times 3 is 6, 6 times 3 18, 18 times 3 54, on and on like that. So let's see some examples. You see that the first value here is 5, second value is 10, 20, 40, 80. So who can guess what the common ratio is? Great, you got it. The common ratio is 2. So you can see, so 5 times 2, 10 times 2, 20 times 2, 40 times 2. So our common ratio is 2. So the nth term of a GP, just like we had the nth term of an AP in the previous video that we did, we can also have the nth term of a GP. So what's the nth term? It is the term that is located at the nth position in the sequence. So I mean, if the n is 5, so it's the term located at the 5th position in the sequence. So we denote the first term by a, and n represents the nth term that we're looking for, and then r is the common ratio. So the formula is very simple, right? We have Tn is equal to AR n minus 1, and we can also prove this. Say we have 5, 10, 20, 40 and on like that. So we know that the a is going to be 5, right? The common ratio is just going to be 10 divided by 5, or I could say 40 divided by 20, anyone, I could just pick anyone, so that's 2. So that means our first term is going to be a, right? Our second term is going to be a times r, which is 10, right? So the previous value multiplied by the r, which is ar. Our third term is going to be the previous term multiplied by r, so that will be ar times r, which is what? Ar squared. Our fourth term is going to be what? You can guess it. Great. So that will be ar squared multiplied by r, which is ar cube, and on like that. So what do you notice? We notice that the Tn, which is the nth term, it is just, so in the second term it was a multiplied by r raised to the power of 1, third term a r raised to the power of 2, fourth term a r raised to the power of 3. So we can say that the nth term is a r raised to the power of n minus 1. Do we agree? Yes. So in the first term, right, our n is 1, so 1 minus 1 is 0, and based on what we've done indices, right, so said anything raised to the power of 0 is 1, right? So a times 1 is just a. That's why we have a here, and this is really just a small proof of the formula. Now we know that the first term is going to be a, second term is going to be ar, third term is going to be ar squared, and on like that. In this example, we're told that we're given the geometric progression 5, 10, 20, 40. We should find the 8th term, 13th term, and the nth term. Now what do we know from here? We know that a is going to be 5, right? We know that the r is going to be, let's say we can say t2 divided by t1, right, which is 10 divided by 5, and that is 2. We know our formula for Tn to be ar n minus 1. It's always important to put a formula like I always say. So the first guy is saying that we should find the 8th term, that's T8. So T8 will be equal to ar 8 minus 1, right, which is something as saying ar raised to the power of 7. So now let's substitute. Our a is 5 times our r is 2, so 2 raised to the power of 7. If you do 2 raised to the power of 7 in your calculator, that will be 5 times 2 raised to the power of 7 is 128. So 128 multiplied by 5, press it on your calculator. What did it give you? It gave you 640, and that's correct. So the next part is saying that we should find the 13th term. So the second question, right, is to find the 13. So that's T13. Do you want to pause the video and try it out yourself? Welcome back. Let's do it together. So T13 is AR 13 minus 1. So that would be AR 12, right? So that is 5 times 2 raised to the power of 12. What is 2 raised to the power of 12? 2 raised to the power of 12 is 4,096. So let's substitute. That is 5 times 4,096. So if we multiply 4,096 by 5 on your calculator, you see it is 20,480. So if you got this, thumbs up to you. Now the last part is saying that we should find the nth term. I. You can also pause the video again and try that yourself. Welcome back. So Tn, right, because the nth term, we'll find AR n minus 1. We have a value for A, we have a value for R, so let's substitute. And that will be 5 times 2 raised to the power of n minus 1, right? Or we can say that is 5 open brackets 2 raised to the power of n minus 1. Still the same thing, any way you want to put it. So we know our first value to be 640, second value to be 20,480, third value to be 5 raised to the power of 2n minus 1. Let's see if we're correct. Great. So our T is 640, 20,480, 5 in bracket 2 raised to the power of n minus 1. Perfect. Well done, everyone. Second question is that we should find the fifth term of this particular guy. You might want to pause the video and try it out yourself. Welcome back. Let's solve it together. So it says find the fifth term of 8 over 9, comma, minus 4 over 3, comma, 2, and on like that. So we know based on this that our A is going to be 8 over 9, right? 8 divided by 9. Our R is going to be, maybe I think for ease I could say T3 divided by T2, right? T3 is 2 divided by minus 4 over 3, right? So if I do this, this will be 2 times 3 over minus 4, right? Which seems like saying minus 6 over 4. Minus 6 over 4 I could reduce and say 2 here 2, 2 here 3. So this, the R is just basically minus 3 over 2. We know that. So our formula for Tn is what? AR raised to the power of n minus 1. So T5 will now be AR 5 minus 1, right? And that is AR raised to the power of 4. So let's substitute. That is 8 over 9 multiplied by minus 3 over 2 raised to the power of 4, right? So let's substitute this. So this is 8 over 9 times minus 3 raised to the power of 4 minus 3 times minus 3 times. By the time you do this, the minus will cancel out and you have 81 over 2 raised to the power of 4. By the time you do that, that will give you what? 16, right? Do it in your calculator just to confirm. So 9 here 1, 9 here 9, 8 here 1, 8 here 2. So at the end of the day, our T5 is 9 over 2. Let's see if we're correct. Great. So we have 4 number 1 over 2. 4 number 1 over 2 is the same thing as saying 9 over 2. So if you got it, well done to you. The next question is saying that we should find the common ratio in the GP log 3, log 9, log 81. So if you remember what we did when we talked about logarithm, so the playlist will appear at the top right. If you've not seen our playlist on logarithm, you should check it out. We know that when we have log a raised to the power of n, it seems like saying n raised to the power of log a, right? Great. So I can rewrite all of these guys and say this is log 3 comma log 3 squared, right? 3 raised to the power of 2, because 9 times 3 raised to the power of 2, comma log 3 raised to the power of what will give me 81, 3 raised to the power of 4, right? So I can also write this as saying log 3 comma, I can bring this 2 down, that will be 2 log 3. I can bring this further, that will be 4 log 3, right? So I mean, it's very easy for me to now find the common ratio. So I could just say R is equal to maybe T2 divided by T1, and that would be 2 log 3 divided by log 3. So log 3 will cancel log 3, and then our common ratio is just 2. Great. Let's see if we're correct. R is 2. Great. Well done, everyone. The next question says that the third and the sixth term of a GP are 108 and minus 32 respectively. Find the common ratio and find the first term. Let's solve this together. So the third term, we're given the third term, we're given the sixth term. So we can say we're given T3, which is 108. So under our given, we're given T3, we're given T6, which is minus 32, right? So told to find the ratio, and we're told to find the first term, which is basically a. So the first thing that we're going to do is we're going to write our formulas. That is Tn is equal to ar raised to the power of n minus 1, right? So we know that T3 is going to be ar 3 minus 1, which is ar squared, right? And we know that T3 in the question was given to be 108. So let me write there and say ar squared is equal to 108. So that will be our equation 1, right? Because T3 is 108. So our T6 is going to be ar 6 minus 1, which is something as saying ar raised to the power of 5. And we're told the value is minus 32. So I come and say ar raised to the power of 5 is equal to minus 32. So this is equation 2. Once again, we are faced with simultaneous equation, right? So if it's something that you're not comfortable with, just try to have an open mind. And when we do simultaneous equation, you can always come back and watch all these videos. So what we do is that, you see this a times the r squared, what is joining them is a multiplication. Same thing too is joining them on multiplication. So we can divide, right? Let's divide. So we can divide equation 2 by equation 1, right? So that would be ar raised to the power of 5 divided by ar raised to the power of 2 is equal to minus 32 divided by 108. So if I divide this, a will cancel this. If I divide these guys, right, since it's the same base and it's division, that would be like saying r raised to the power of 5 minus 2, right? Which is saying r raised to the power of 3. So we know this from indices, right? So for these guys, minus 32 divided by 4, minus 32 divided by 108. Let's see if 4 can go. So 4 here 8, 4 in 10 is 2, carry over 2, so that will be 7, right? So we have this guy to be minus 8 over 27, and if I just wrap this down, so this will also be equal to minus 8 over 27. So how can we find r, right? This r raised to the power of 3 and this guy, so we can find the cube roots of both sides. So we can say taking cube roots of both sides, right? So that would be like saying cube roots of r cube is equal to cube roots of minus 8 divided by 27, right? So if I take the cube root of r cube, what is going to remain? It's going to remain r, because it's like saying r raised to the power of 3 raised to the power of 1 over 3, right? So if you also did what we did on indices, I think this was, we covered it on the playlist will appear at the top right, so you can always reference that. So I mean, it's like saying the same thing, so we can cancel out. So this would be like saying we're left with r, right? And this cube root, so if I set the cube root of minus 8, if I do minus 2 times minus 2 times minus 2, of course I'm going to get minus. So that means the cube root of is minus 2 divided by the cube root of 27. 3 times 3 times 3 would also give me 27. So like this is 3 3's, so the cube root of 27 is 3. So that means our r is equal to minus 2 over 3. Are we done? Is the mission accomplished? Not yet. So we have the second part, which is the first term, right? We're told that ar squared is equal to 108, and we know the r, right? So can we find the a? Yes, we can. Pause the video and try it out. Try and find the a by yourself. Welcome back. Let's do it together. So we know ar squared is equal to 108. I mean, I could have used any of them. I just used the ar squared because it looks easier. So let's substitute. That will be a open brackets minus 2 over 3 all squared is equal to 108, right? So this a times minus 2 squared is going to give you 4, because minus 2 minus 2 is giving you 4, all over 3 squared is going to give you 9, because 3 times 3 is 9. So this is equal to 108, right? So if I wanted to make a stand alone, I could just cross multiply, really. So if I cross multiply these guys, that would be a times 4 is 4a. You know what I always say, that if you have this 108, I'm saying 108 divided by 1, right? If you're following these videos consistently, this should not be strange. So we have 4a is equal to 9 times 108. So that will be 108 multiplied by 9. So to make the a stand alone, I can divide both sides by 4. Let me divide this side by 4, divide this side by 4. So a will be equal to, so if I press on my calculator, that will be 108 times 9 divided by 4, and that gave me 243, right? So if you got 243, well done. Let's see if our answer is actually correct before I even say well done. So our r is minus 2 over 3 and our a is 243. So we can say thumbs up to everyone that got it. So let's look at the next question. It says that a GP has the first term of A, a common ratio of R, and its sixth term is 768. Another GP has a first term of A common ratio of 6R, and its third term is 3456, which should evaluate A and R. So what do we have? So if I put our given, we are given two GPs, right? The first one, it has a first term A, right, a common ratio R, and the T6. So you can say A is equal to A, R is equal to R, and the T6 is equal to 768. So the other one has a common ratio A, the R is 6R, and then the third term, which is T3, is 3456. So let's evaluate. We know our general formula for Tn. Tn is what? Great, so well done, you remembered. So AR raised to the power n minus 1. So our T6, right, will just be AR 6 minus 1, which is something as saying AR raised to the power of 5. And they told us that the value is 768, so I could say AR raised to the power of 5 is equal to 768. This will be like our equation 1, right? So let's go to this other guy. T3 is what? AR raised to the power of 3 minus 1, right? So that would be AR squared. But we know our R to be what? Our R is 6R. So let's substitute. That would be A open brackets 6R all squared, right? And that's something as saying A times 36R squared. 36AR squared. So after substituting the value of A and R for this guy, we have 36AR squared for the third term. And we thought the third term is 3456. So let's substitute it and say 36AR squared is equal to 3456. So before I make it a equation 2, I would like to make the AR squared stand alone. So I could divide both sides by 36. If I divide this side by 36, I divide this side by 36. This will cancel this. So if you take your calculator out, I want to take your calculator out and try 3456 divided by 36. Right, what are you going to have? Right, I did it on my own and add AR squared to be equal to 96. So this is 9 and this is 6. So these are equation 2. So we have our equation 1, we have our equation 2. Do you guess what we're going to do next? Great. So we're going to divide, right? Just like we did in the previous example. So this will be equation what? Equation, let's say equation 1 divided by equation 2. Right, and that will be AR raised to the power of 5 divided by AR raised to the power of 2 is equal to 768 divided by 96. So if I cancel out, A will cancel out, R squared will cancel out, just like doing the previous. This will return R cube, right? I mean, from the laws of indices that we know, we could say R times R times R times R divided by R times R, then we'll cancel out. That we'll have R raised to the power of 3. So 768 divided by 96. I want to take your calculator out and try it. Your R cubed will be equal to 8. So how can we find the value of R? Right, so we could find the cube roots. So we could take the cube roots. So the cube roots of both sides, right? So that will be cube root of R cubed is equal to, okay, this cubed is equal to the cube roots of 8, right? So R, if you find the cube root of R cubed, we're going to be left with R. And we've solved that plenty of times. And if you do the cube root of 8, the reason I can give you 8 is 2 times 2 times 2. Minus 2 times minus 2 minus 2 will give you minus 8, but only 2 times 2 times 2 would give you 8, right? 2 in 3 places. So that means that the R is equal to 2. So that means our ratio is equal to 2, right? So the cell should find the ratio of should find A. So based on that, I could use any of the equations that have A and R squared. So let me see, is there a simple one? Yeah, so I can use this one. This AR squared is equal to 96. So let's solve. So substituting in equation, so this is equation 2, AR squared is equal to 96. So that will be A times 2 squared is equal to 96. 2 squared is 4. So that will be A times 4 is equal to 96. And if I divide both sides by 4, I'll find my value of A. So 96 divided by 4, that is what? 24. So we found our A to be 24 and then our R to be 2. Let's see if we are correct. Great, so our A is 24 and then our R is 2. So the next question is saying that a ball was dropped from a height of 80 meters above a concrete floor. It rebounded to the height of half of the previous height at each rebound. After how many rebounds is the ball 2.5 meter high? So you know when you just drop something from a height, you need to come to be bouncing, to be bouncing, to be bouncing, to bounce. But at every time it's bouncing, you remember that the height of the bounce will be reducing until it comes to a final stop, right? So just saying that initially they jumped from the height of 80 meters, but at every time the thing bounced, right, it was reducing in height by half. So you can see a geometric progression there. They're not saying that after many of those bounces would the height be 2.5 meters. So we're trying to find the n. The n will be the number of bounce, right, that would equate a value of 2.5 meters in height. What are we given? Our A is 80 meters, right? The ratio is half because it's going to be reducing by half at every time. Then we want to find after how many rebounds is the ball 2.5 meters. So that means we want to find the n, right? The nth time that the value, which is the tn, the value at that end will be 2.5 meters. Great. So we know first is that our formula is tn is equal to ar raised to the power of n minus 1. So our tn is 2.5. Our a is 80. Our r is half raised to the power of n minus 1. I can be able to break up this half raised to the power of n minus 1 from the laws of indices that we treated before by saying 2.5 is equal to 80 times half raised to the power of n times half raised to the power of minus 1, right, based on what we did there. Now I know that this is like saying the inverse of 1 over 2, or I could say this like saying 2 raised to the power of minus 1 multiplied by minus 1. So minus 1 times minus 1 will give me plus 1. So I don't know that I will have 2 raised to the power of 1. Right, or you can look at it as saying anytime you say minus, like saying the inverse. So if I carry this 2 up and I bring this 1 down, what will I be left with? I'll be left with 2. So 2 raised to the power of 1 is the same thing as saying 2, and 1 over 2 raised to the power of minus is the same thing as saying 2. So if I do that, that would be 2.5 is equal to 80 times 1 over 2 raised to the power of n times 2. 2 times 80 is 160. So that is 2.5 is equal to 160 times half raised to the power of n. So for me to make this half raised to the power of n stand, I have to divide both sides by 160. So I could say 2.5 divided by 160 is equal to half raised to the power of n. Now this 2.5, you agree with me, I can say it's same as saying 25 over 10, right? Do you agree with me? Yes, 25 over 10. So 25 over 10, I mean if I bring this part, I could say also say times 1 over 160. Right, because I'm trying to divide 2.5 by 160. So it's like saying 25 over 10 times 1 over 160 is equal to half raised to the power of n. So let's divide and see what we can do. So 5 can go here, 5. If I do 160 divided by 5, that will give me 32. So this is 32. Right, also 5 can go here 1, 5 can go here 2. So if I reduce this is like saying 1 over 2 times 32 is 64. Right, is equal to half raised to the power of n. So can I be able to express 1 over 64 in terms of 1 over 2? Yes, I can. If you look at it, if I do 2 times 2 times 2 times 2 times 2 times 2, that is 2 in 6 places. That will give me 64. You can try it out. Take your calculator. So you could say 2 raised to the power of 6. Right, that will give you 64. So I could represent see this like saying, and if I do 1 raised to the power of 6, 1 times 1 times 1 times 1 times, see the same thing as 1. So I could say this like saying 1 over 2 raised to the power of 6 is equal to 1 over 2 raised to the power of n. And if I do comparison, right, comparison, this have this n, and since they're equal, they have the same base, that means my n is also equal to 6. So if by chance you don't know how we got 2 raised to the power of 6 to be 64, you can do the long division and say 64, 2 in 64 is 32, 2 in 32 is 16, 2 in 16 is 8, 2 in 8 is 4, 2 in 4 is 2, 2 in 2 is 1, right? And how many 2's do you have? You have 1, 2, 3, 4, 5, 6, right? So that is how we knew that 2 raised to the power of 6 will equal 64. So you can see that n is equal to 6, and that's correct. Let's go to the next question. So it says 3 numbers form a GP. If the first and third numbers are 5 and 245 respectively, find the 2 possible values for the middle number. So what are we given? We are told that the first of the numbers is 5 and the third number, which is C3, is 245. We're trying to find the two possible values for the middle number. Now we know our formula for Tn is AR raised to the power of n minus 1. So Tn is T3, and that is equal to AR 3 minus 1, and that's equal to AR squared. Let's substitute. So that will be 245 is equal to A is 5, so that will be 5R squared. If I divide both sides by 5, right, this will give me 49. Right, 49 is equal to R squared. Right, so what times is that I can multiply that will give me 49? I can multiply 7 times 7, and that will give me 49, and I can also multiply minus 7 times minus 7, that will also give me 49. So that's why we will say when we're doing R, right, when we are doing square roots, we know that there are always two possibilities, right? So if I take the square root of both sides, so take the square roots of both sides, what would that give me? So that's like saying square roots of 49 is equal to square root of R squared. So if I take the square root of both sides, that will be R will be equal to plus or minus 7, right? So that means our R could be minus 7, or our R could be 7 or plus 7. So if A is 5, right, the T2 is A times R, right? AR. So our T2 could be 5 times 7 or 5 times minus 7, and that is 35 or minus 35. So the two possible values for the middle number is actually 35 or minus 35. Let's see if we are correct. Great, so plus or minus 35. Now the last question says that the third term and the sixth term of a geometric progression are 48 and 14/2/9 respectively. Write down the first four terms of the geometric progression. I want to take out a pen and solve this together with me. We need to first write what we're given. So T3 is equal to 48. T6 is equal to 14/2/9. Do you want to pause the video and convert this to an improper fraction? Welcome back. Or how can we do this? We say 9 times 14 plus 2, right? And that is 128 divided by 9. So that is our sixth value. So what do we know? We know that T3 is equal to AR raised to the power of 2, right, from our general formula. And we know that T6 is equal to AR raised to the power of 5. So do we know the A? We don't know the A, right? So that means that AR squared is equal to 48. I could say this is equation 1. And AR5 is equal to, so this is 5. Forgive my handwriting. This is equal to 128 divided by 9. And this is equation 2. So if I divide equation 1 by equation 2, let's still maintain the same format to be using. That will be AR squared divided by AR raised to the power of 5 is equal to 48 divided by 128/9, right? So let's see. A will cancel A. R squared will cancel R. So what will remain will be R cubed. So what I will have will be 1 over R cubed is equal to, if I do this, this will be like 48 times 9 over 128. Yes or no? Great. So let's see. Can 128 divided by 24? No. Can it be divided by 12? Let me see. I'm pressing on my calculator. No. So let's see. But 120 can be divided by 4. So 4 here is 32. 4 here is 12. Right? 4 here is 3. 4 here is 8. So what I have here is 1 over R cubed is equal to 3 times 9 is 27 all over 8. Right? So if I wanted to, I mean, this is 1 over R cube and this is 27 over 8. If I want to make the R cube come on top, I can just take the inverse of both sides. So take inverse of both sides. If I take the inverse of this side, that is like saying R cube. Whatever I do to the left, I must also do to the right. And if I take the inverse of this guy, that will be 8 over 27. Or if you wanted to do it alternatively, you could cross multiply, right? And you make R cube set of the formula. You can try that out. You will see that you arrive at the same thing. So if I want to find the R, that means I need to find the cube root of both sides. So taking cube roots of both sides. So that would be cube roots of r cubed is equal to cube root of 8 over 27. Cube root of r cubed is r. Cube root of 8 over 27 is 2 over 3. So that means the r is equal to 2 over 3. But is that what they said we should find? No, they said we should find the first 4 terms. So if you know the r, we can be able to find the a, which is the first term. So we know that ar squared is equal to 48. Pause the video and find the value of a. Welcome back. So let's do it together. So that is ar squared is equal to 48, right? So if I substitute, that would be 8 times 2 over 3 all squared is equal to 48, right? So this is like saying 8 times 2 squared is 4, 3 squared is 9, so it's equal to 48. So I can make a substitute formula and say a will be equal to 48 times 9 divided by 4. So let's see, 48 times 9 divided by 4, and that gave me 108. So my first term is 108. So if I want to find the first 4 of all of them, I have the r, I have the a. How would I do it? So the first term will be 108. The second term will be 108 times the ratio. So that will be 108 times 2 over 3. Right? If you do that on your calculator, so 108 times 2 divided by 3, that will give you 72. Right? Then the third term will be 72 times 2 over 3. So that is 2/3 of 72. That is 48. Right? And then the last one, you said we should find the first 4. So if I do this, so this will be 48 times 2 over 3. So 48 times 2 divided by 3, that is 32. Right? So the first 4 terms are actually 108, 72, 48, and 32. So these are our 4 terms. Let's see if we are correct. Great. So 108, 72, 48, 32. We're actually done with geometric progression. This is how you solve questions that contain geometric progression. You look at the formula, you look at what's given, and try to make postulations or try to arrive at a solution. In the next video, we'll be looking at some of a geometric progression. That particular topic is, when I checked the WAEC syllabus, it was excluded. But I feel like it would be good to know for anybody that wants to actually know how to add sums of geometric progression. See you in the next video.